Howdy, Coop. You doing all right? Bring that down a second. All right, so I did move over to the new laptop, so hopefully things go well. We'll see. Should have everything. Learn. So we are on week 3, and week 4 is Memorial Day, so we've got a bit of a break. My plan for weeks with holidays is we just pretend they don't exist. So everything that would be due within a week will just get bumped out. So the lab for tonight, we'll have 2 weeks to do it because we'll just pretend those weeks don't happen. So you can actually have a Memorial Day and hopefully not worry too much about it. So that first project, project 1, our fence supply calculator, then is June 6th, right, 6 p.m. This one we got a little more time. I know that the 4th of July kind of messes up this a little bit as well. Oh, you can barely hear me? Give me 1 second. Let me see. Do I need to do gain on this? This is what I forgot to try. No, it's defaults. Maybe my filters are bad then. I turn off noise suppression. Is that any better if there's no noise suppression? Because it's set to go up all the way. Okay, it's okay for you, Brian, before you even change that? So forgot that one's a little harder to test because I have to have 2 people to test it, and I forgot to. Oh, no, my desktop audio is down. Mic is normal. Okay. Well, let me, sorry, play with that for just a second here. Maybe I can increase it. Is that any better? Any louder? I'm not quite hitting the yellow, but. Okay, you got it on your headphones. It might just be you, Lord Taser. We got 2 other people saying it's okay. Let me put that noise suppression back on then, because that is obnoxious. All right, it should still, yeah, I think I still got the right bars coming in here. Okay, yeah, sorry about that. All right, so looking at this week, next week we're off, and then picking it back up after. And we've got conditionals as chapter 3 today. The chapter 2 quiz, which I did write, so there might be typos in it. If you are not sure about the questions, please let me know. Is due by 11:59 p.m. tonight. I'll try and do quizzes due by like midnight so that I have one last chance to remind you of it by the time you show up. But the labs and the projects need to be due before class starts because we're going to go over the answer to the projects. If you want answers to the quizzes, they should open automatically. And if you have questions about them, then let me know. So by the time the due date hits, they're set to show the answers, right? And then, because that way, not that you folks would collaborate on it, but it keeps you from submitting your quiz and then sharing what you got right, what you got wrong with everyone else and seeing the answers. So just makes me feel ever so slightly better about it as we go. So no class for Memorial Day, then we'll pick it back up with chapter 4, 5, 6, 7. Moving on, our third project then again gets upset by the 4th of July, so we'll pretend this week doesn't happen. Here, that project will be due 7/11. So that night, I'll go over the answers to project 3, or the solution to project 3. We'll do some review for the midterm, and then you'll have that entire week to take the midterm exam. Again, I'm not fond of timed exams. Like, whether or not you can do something right is more important than whether or not you can do it in a 2-hour sitting, because very rarely does that ever happen in the real world. So, I mean, there are like, you have a certain amount of time to finish things, but it's not sit down for 2 hours, don't get up and do this right, or go home. So I think that's a weird way to go about it. And then we'll pick up our 4th project, and then 8/1. I know looking into August already, we start the final project. Sorry, I'll move that up. We start the final project, and that is the last month of class here. And then the last day, actually, we'll do a Zoom session for anyone who wants to join remotely. We'll actually present our final projects and have a little bit of fun showing off what we did to the class. So it's better if you do it in pairs, I like to imagine at least. It's a more collaborative experience. You get to bounce ideas off of each other. It really, 2 heads are better than 1 when it comes to creative problem solving. And that's what all of our programming is. It's the hard part is taking a big problem and breaking it down into smaller and smaller and smaller steps that a computer can solve it for you, right? Because we have to have really, really, really tiny steps to make a computer solve a problem. So that's the hard part. The syntax is going to feel tough because we're learning a new language and figuring out, what do I have to type, what goes where, how to make those red lines go away is obnoxious, but that's not necessarily the hard part, right? So a good programmer, you need to be creative and a good problem solver, because very rarely do you get a problem in the real world and someone will sit you down and say, okay, do this step, 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 do this step. You just translate it into Python and they'll give you like a complete set of directions. It doesn't really work like that. Like we get, hey, let's go see if we can't, graph this data over here. We'll go get some data from online, go graph the data, see if there's any relationships in it. You do all sorts of fun stuff. All right, so that's where we're going. So let me fire up a new project here. This will be week 3. And again, for your labs and your projects, you'll have a new repository for each one. That just helps keep things separate for you. So each one's in its own folder, keeps things nice and clean, and then things don't need to change in between. So when I go look at it, the files won't have changed by mistake or anything like that. So, but for my examples, I'm going to put them all in one repository for you and just make a project each week. That way there's only one link you folks need to go look at to find the stuff if you want it. Documents GitHub. So I'm going to put it in our 2131 summer 2022 folder, and then I'll call this project. We'll say this one is week 3. Excuse me. Oh, and didn't have a previously configured interpreter. Okay, let's do. We can do the new virtual environment. That should be fine. And we'll make that. We'll just take just a second for it to make it. All right, and again, we get the starter code. We can just clear out if we want here. Not too big of a deal. And you can always check, right? If you hover over this project folder view, I know it's a little small on the screen there, sorry. You'll see where the path is for this. So I can see it's in my GitHub folder, and if I check my GitHub client, it should find some new stuff. Here's a week 3 main file. Right? It's empty right now because I haven't put anything in here, but it sees the file was created. So we're looking pretty good. We got it in the right spot, and now we'll be able to save that later on. Can't put a top on Bob. Just don't want to spill it. We're not supposed to eat and drink in here. Zoom hotkey. Right, getting a new computer is obnoxious. I'm sorry. So I want Zoom. Where is it here? Zoom in and out. Not images. Font. Increase font size. There we go. Need to add a mouse shortcut. And decrease, control down. Thought those used to be defaults. I don't know why it's not. There we go. So now that'll zoom a little better. So what we have done so far with talking about how we can create variables, do basic arithmetic, work on, hey, we'll do some math, right? And then figure out what we need. So our first project then was our fence calculator. Now I asked for a couple things in here. I'll try not to do that again, but we've only really had like 1 week of Python. So the little bit we need to add this week won't be too bad here. So we're going to ask the user a bunch of details and figure out how many supplies they need to buy. So they tell us the size of the rectangular fence in the length and width. Then we'll ask them how far apart the posts should be. Right, so we have a total length and width, and then we have posts every so often on this fence. We'll do this checking to make sure it's evenly divisible this week. We'll figure out whether or not that actually works or not. For now, you could just assume they're going to tell you something correct. So if you say, I want posts every 5 feet, then the total distance should be something divisible by 5. Right? If you want a 14-foot fence and you say you have posts every 5 feet, that just doesn't add up right. But we'll look at how we can check that this week. As of last week, we assumed it was the right number. So we need to calculate the number of posts we have to buy, and then we'll ask them, hey, what length of board are you going to buy? What's on special this week at Home Depot? Right? Maybe the 6-foot board's on sale for whatever reason. So take the post distances and see how many pieces we can fit for each board. So if I'm buying a 6-foot board and I post every 5 feet, I'm getting 1 post distance per board. Right? That extra foot just gets cut off and thrown away. If I have posts every 2 feet and I buy a 6-foot board, I can go 3 posts. Right? So actually from 1, 2 feet, 3 feet, or 2 feet, 4 feet, 6 feet. So I'm actually covering from 1, like 4, it's nailed to 4 posts, essentially. because that's the distance between them, but we're covering 3 of those gaps that we need to. So we need to figure out how many boards we need to buy. So we talked a little bit last week about good numbers to test with, right? If you're building a 10 by 10 fence and you buy a 10-foot board, it should probably tell you need 4 boards, right? If you're building a 10 by 10 fence and you buy a 40-foot board because you cut down a tree and milled it yourself, you probably only need 1 of those suckers, right? A 40-foot length board can do the perimeter of your fence across all the posts, right? If you have posts every 1 foot, right, and you buy a 1-foot board, you probably need 40 of them, right? There's a couple of numbers we can use to do some quick tests to see, is it going to do the right thing for us? Okay. And then we're going to multiply that, right? How many boards do you want across each post? So if I want like 3 boards, a top, a middle, and a bottom here, well, I need 3 times as many boards as I needed to just do 1. Because most of the time, you're not just going to do a post at the top or a board at the top and leave the rest open. I mean, maybe you do because that's how you want to build your fence, but that's fine. We'll ask them how much each post costs and how much each board costs. And we'll tell them the total number of posts, the total number of boards, and the total cost of each, and the grand total for the project. So a bunch of different inputs, right? And anytime we're dealing with numeric inputs, we need to do conversions. Right? Anytime we use input to get some input to get input, right, is giving it to us as a string. So if you're going to do arithmetic, we need to convert to an int or a float. Now, you probably don't want people to tell you weird floating point numbers for distances, because that will just make life awkward, right? Maybe you do, and that's up to you. But if you just assume everything is an integer, I'm cool with that. Right? I'm not going to check with floats and say you did it wrong. So then in terms of what you're going to turn in, right, the URL to your main PY file and a self-assessment using the rubric. Now, again, I wish the rubric was like point and click for you guys. It's point and click for you when I grade, but you get to see it. So just for each of the items, tell me how many points you got. You can number them if you want. You can copy paste them if you want. But this is your chance to see, oh, hey, I did the thing. Like I'm asking the user for the dimensions, length, and width. Good, I get my 2 points. I asked the user for the size of the post distance and board size. 2 more points. Calculate the total number of posts. Calculate the total number of boards. Calculate the total cost of the project. There's your 10 points. Okay? And again, the sanity checking we'll look at today, how we can start checking to see if something actually is what we expect it to be. Does that make sense for what we're doing with this one? Bless you. All right. Submit it? Yeah. So it should just ask for text. So you just paste in the URL and then just tell me, hey, for rubric item 1, 2 points, rubric item 2, 2 points, rubric item 3, 3 points. It'll just be a text box. Like when you go to submit, just like the labs, just have a text box. You just type it in there. Yep. Yeah. You're welcome to give yourself partial points if you didn't get it all 100%. If you're not getting 100% on it, hopefully I've heard from you. Because if something wasn't sure or you're having trouble, that's your clue. You should go ask. Right. I'm happy to help you make sure you get pointed in the right direction. Now, I'm not going to solve it for you necessarily, but I'll get you unstuck and help point you to what you need to do or what you might need to go look at. Some helpful hints there. Again, it's not a math class, so like if the math part has you really stuck, I'll help you with the math. It's okay. We're not teaching math necessarily, but just using some basic algebra here. It's not even algebra; it's just arithmetic, I think, at this point. But happy to help with that. Okay, we have till the 6th for this one, so should have plenty of time after class today. We can work on the lab, we can work on the project, but then before we meet next time, it'll be due. So happy to work with you remotely, right? We can meet on Zoom or Discord or whatever. If you want to meet in my office, we can meet in my office sometimes too. Generally, I'm only there before class, so let me know. But we can do that. All right, so moving on to new stuff. So one of the things students tend to care about a lot is their grade point average. Unfortunately, scholarships and things tend to rely on grade point average. And sometimes companies, I guess it's probably more often than not, companies will use GPA as a way to filter out potential interns. So I know, I think it's Ford won't look at anybody who doesn't have a 3.5 or higher, which I think is a terrible policy, but that's okay. You know, I don't manage the program, so, and they have to do something because they get a bunch of applicants. So, but when you look at GPA, right, it's essentially your letter grade gets turned into points, and then you do a bunch of things with it. You add them up and you take an average. So we could ask the user, to enter their letter grades, and we could do some conversions for them and calculate their GPA. Right? So if we want to know what letter grade they got, we can ask them. So we'll say, hey, here's their, I don't know, we can do like 3 classes maybe. We'll just make this up and say you have 3 classes. So first class letter grade will equal an input of enter your letter grade for class number 1. And I'm pretty much just going to copy paste this, and we'll do it 3 times here. So we'll have a first class, we'll have a second class, we'll have a third class for class number 2 and class number 3. Again, you don't want to start with numbers for your variable names. Like, so you can't do like 2 and D. That's an invalid name. It's got to start with letters. So a little bit funky here. You could do like letter grade and then a 1 if you wanted. I don't know. You can come up with your own names. Now we need a way to go and see, well, what is the grade point for each of these? Right, well, right now we don't have a way to do that. We haven't figured out how to do that. So what we're going to do, we're going to say, hey, is the thing that they entered equal to something else? Right? And we see the single equal sign here is not checking if something equals. It's assigning a value. It's saying take the thing on the right and assign it to the thing on the left. So this is the assignment operator for us here. So to check if something equals, we use 2 equal signs. So sure, we could say, hey, if the first letter grade equals, quote, A. And then we put a colon in. So the colon in Python means that I'm about to write some code that belongs to this block above. So in PyCharm, as soon as I hit enter, you notice it's going to be tabbed in, or actually 4 spaced in, because it uses spaces here, but it's indented. So this code is going to belong to, if this is true, we'll go do this operation. Well, if I'm going to calculate, well, let's pause on these for a second. Let's just do 1 to start. So I'll comment those out. We'll come back to these in a minute. Let's just do 1. So if it's an A, then I'll say your grade point is going to equal 4. Right? So if you got an A, if the whatever you entered here equals an A, so they could type anything they wanted. They could type in apples. If it doesn't equal the letter A, if it doesn't match, and this is a capital A as well, we'll get into casing later. If it's an A, we'll say it's 4 point here. Okay, that's not too bad. Then we could check, hey, now, again, when I enter down, it stays indented. You can put as many lines of code here as you want, like attached to or associated with or inside of this block. Right? Anytime you've got indented code, we say that's a block of code. So this is the if this is true block, this will run. Right? So then you need to go down another line here before you start something else. So I had to go down, so I had to backspace to go back that tab, and then down another line to start something else. Then I could check, hey, if my first letter grade is equal to double equal sign, and A minus. All these keys are in a slightly different spot here on this keyboard. It's going to make me confused. Hey, Cheeky, thanks for joining online. So if you got an A minus, then your grade point will be a 3.7. Okay, and then we can say, hey, if your first class letter grade is equal to a B plus, your grade point is going to be a 3.3. Right? I think that's what it is. Let me CC grade policy. Double check. Yeah, 4.0, 3.7, 3.3, 3, 2.7, 2.3, 2, 1.7. And notice here, by the way, a C is considered average in a college course. Just keep that in your pocket as an FYI. A C is average. Yeah.
I have a question. Why does the Python compiler, if you put the grade point equals to 4 right there, but then outside the if statement, if you used it, it doesn't recognize it?
Like if I go print grade point here?
Right, but if I had deleted line 11 and 12, 9, because the if statement wasn't executed, it didn't see the variable of that.
Mm-hmm.
And then I get a compiler. Does it compile? Get an error?
Yeah. So this will only exist if this block of code runs. So if this is not true, then this line of code never runs, and you've never told Python, hey, I've got something called grade point. So when you go use it down here, it's going to fail. All right. So we run this, and I give you, a B. we get this error here. It says name grade point is not defined. We've never said, hey, Python, I've got this thing called grade point, because this line never ran.
It's just a little bit different than other programs.
Yeah, so Python will let you try it because it's like, oh, it might exist. It's not going to warn you that it might not exist. So other languages are a lot more strict about that and just won't even run at all. But Python's like, sure, try it. Go for it.
Should we always initialize the variable in the beginning?
You could, yeah, so we could start it off as grade point.
Yeah, just put it as
starts at 0. Sure, yeah, we could do that. So we're going to fix that in a minute with the rest of this checking here. But yeah, so if you want to not run into errors, which is really good because errors tend to upset our users, right? Like for some reason, I get really upset when apps on my phone crash. Probably because I know like they could have done better. They shouldn't crash with the way we can program things nowadays, but like that just frustrates me that I don't want to use that app anymore. So if you set it at 0 to start, then it is either 0 or will turn into a 4 if that's true, and you won't run into this error. Yep. Let me uncomment those back out. And we'll just keep working our way down here, right? So then we can probably copy paste a lot of this here then. So then if it is a B, that's a 3. If it's a B minus, it's a 2.7. That's right. Right, and then a C plus is a 2.3, and then a C is going to be 2. A C minus will be a 1.7. A D plus is going to be a 1.3. And then what is it? A D is a 1. You'll need one more here. D is then a 1. We could add in an F if we wanted, right? Because that's sort of what this chain has here. F is a 0 here. Sure, we could add that in. So we'll do one more here. Say, hey, if it's an F, we'll set it to 0. I'm sorry? Yeah, yep. We're going to get to that in a second. Yep. So this is all just, yep, this is all if checking. So each one of these will get evaluated here. So again, if we want to, I can put a breakpoint in here, right? You click next to the line number, and instead of hitting run, we're going to hit debug, and we're going to watch Python run and see what it does at each one of these. All right. So what letter do you guys want? B plus. All right. Okay, B plus. So now first class letter grade is set to a B plus, and now I'm ready to start stepping. So you got a couple arrows. Again, usually the step over is your best bet here for most of these. So we're going to step over. Now grade point is now set to 0. So I have a first class letter grade and the grade point set to 0. Sorry, I can't zoom these. Zooming's a little awkward on it. And now it's ready to run line 7. So the line that's highlighted is about to run. So when I step over, it's going to run it. It's not true. So everything inside of this block here doesn't run. Then we'll see A minus. No, A minus isn't true. Nothing happens. All right, how about B plus? We'll step. Now you notice I went into that block. So this one was true when we said, hey, does your letter grade equal a B plus? It was true, and now line 14 is going to run. We'll set our grade point to 3.3. And we'll check this one, we'll check that one, we'll check that one, we'll check that one, we'll check that one, that one, that one, that one, that one, and then we'll print it. And we see, okay, 3.3. Okay. Now notice that they like kind of got stuck together here, these inputs. So if you like things to be like brought down a line all the time, you can either add a new line here, or those new lines are the backslash n's if you want new lines. I don't really like having to put all those in, so what I usually do is I'll just put an empty print, and I'll just say print. Print by itself will give you that new line, so that now my output will be moved down, because input will show something and not move down a line. So if I just run it and do B plus again, we get 3.3. And the prompts are a little funny, like it's touching here, so maybe you like the backslashes, because then your prompt is on that line. You got a couple choices, however you want to make that work. But you saw Python went and looked at each of these and said, okay, is it this, is it this, is it this, is it this, is it this? Now it's really fast, and we don't really notice it taking, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different comparisons, because it goes a lot faster than we can. But it'd be better if we didn't have to check all of these, because we happen to know that if you are the letter B plus, you're not any of the other ones. right? So what we want to do is we want to attach these together and say, okay, only one of these will be true, right? At this point, the letter that you have is mutually exclusive. You can't have a B plus and a B at the same time. Right? You get one and only one of these choices. That's mutually exclusive is our fancy term for that. So instead of all of these being if, where Python has to look at all of them, we're going to use a fancy term. Now in other languages, it is known as else if here, but our friendly people in Python said, oh, let's do elif. They said, okay, if this is true, else if this is true, elif this is true. Oops, oh, F1 is not the key I wanted. Elif this one is true, elif the helpful type ahead is not so helpful here. Elif, 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 elif. Now what this lets me do, which is really nice, is you can also have an else case. The else case is if it's not true, else this. So I could say, is it hot out? And you're either going to tell me yes or no. If you say yes, I'm going to wear my shorts. If you're going to say no, I'm going to wear my pants. Sure. So if and else, we can do this in the same chain as well. So I can say if, else if, else if, else if, else if, and then just else here. And I don't even need to check, because if it's not an A minus, a B plus, a B minus, a C plus, then you didn't get any grade points here. So I can just have this last else here. This is known as like the default case. So if it's not any of the ones above here, then you'll get 0. And what that lets me do is I don't have to declare it up above here, because I know one of these is actually guaranteed to run, because it's either one of the letters I've specified, and if it's none of the letters I've specified, this else will run. So we're kind of matching. We're saying, okay, is it this one? No. How about this one? No. How about this one? How about this one? How about this one? And if it's not any of the ones I've said, here's your default. Here's your else. And kind of stick them all together here. So it lets me avoid having to declare it here, because I have this if, else if, else if, else if, else if chain here. One of them has to run. When they were only ifs, none of them had to run. Right? It's possible I entered apple, and apple is not an A, it's not a B, it's not a C, right? It doesn't fit any of them. So it's a better way to do this sort of matching here with if, else if, else if, else if, else if, else. So now we run this, and we say, okay, what's your grade here? We say apple, we get 0. We should probably make this even prettier, right? So we'll say your grade point is, oh, we don't need the space here for comma separating. Make that look a little prettier. And now if I say, hey, B plus, we'll get 3.3 for a GPA. Right? It's not too bad. Excuse me. So now we need to do second and third. Yeah.
So the elements, once it found the B plus, from the rest.
Yes, thank you. Yeah, I forgot to show that. So let me show that in debug mode here. So in debug mode, as soon as one of these matches, it doesn't even bother looking at the rest. So it's going to be faster, because probably most of the time people aren't failing. They're getting some sort of letter grade most of the time, right? So you want to put your most common thing first. Is a way to kind of speed up your programs. So let's go back to B plus here. And now we'll see what happens. We'll step. We'll say, is it an A? No. All right, how about an A minus? No. Is it a B plus? Yes, it's a B plus. So now this block of code will run, and then the next line that runs is all the way down to here, because all of these other ones are skipped because we found one that did run. When they're grouped together like that, it's a chain of them. One and only one will run here. So it's a nice way to actually speed up our code as well. It's a smarter way.
What if it wasn't A? That was check. So if it was A,
yep. Nope, nothing else runs, because it's really saying else if. So else if.
Once it runs into that first element, it says you already had something without going to the bottom.
The first one that matches, none of the rest that follow will happen. Sorry, I'm just trying to catch up here on chat. Cheeky, we can talk about that later. There's definitely ways to play wave files for sure. All right, so we've got this, and now we really need to ask them again and do the same process again. So we're going to feel bad about ourselves, but we don't know how to do it better yet. So I'm going to copy paste all of this essentially here. So I'm going to take grade point. Now, if I'm going to be totaling your grade point and then summing it and taking an average, right? I don't want it to set it to 4 every time. I want to add 4 to it. Right? So if we have 3 classes we get grades for, we're going to add all 3 grade points together and divide by 3 to get your grade point average. Right? So I do actually want to set it here to 0 to start, and then all of these I want to be plus equals. I want to say, hey, let's add to it, please. Let's add to it, please. Right? The combined assignment operator, because we don't want to have to type something twice. And really, we don't even need to add anything here. I mean, you could say plus 0, but plus 0 does nothing. So it's sort of silly at this point to have this default case, but that's okay. We can leave it in for now. It's not hurting anything. Doesn't actually do anything now, right? And we're going to repeat now for the other letter grades. So I'm going to ask for second, ask for third. I'll take all of this code here. We'll copy it. I'm going to paste it in. All right, now here's what we want to do. We want to do this, do the least amount of work possible, right? I don't want to have to go type second, 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 second every time. So what I'm going to go do, I'm going to grab second. Now, I'm a big fan of keyboard shortcuts, so I'm going to use them all the time. So if you double click on a variable name, it will highlight everything for you. It'll highlight a word. A triple click should highlight the entire line, and that should work in just about any program. So double clicking will highlight an entire word, and then triple clicking should highlight the entire line if you want a fast way to select something for copying. So I'm going to double click here, Control C for copy, and then if I wanted to, I could go and manually double click to highlight, Control V for paste. Double click to highlight, Control V for paste. That's even too slow for me. I don't want to do that. So I'm going to do a find and replace. So in here, you can go to find and replace, and I want to replace my first class letter grade with the second class letter grade. I don't want to use replace all because I want this first set to stay checking the first one. Right? The second set, though, I want to start replacing. So I'm going to go to the next match here inside of where I started checking seconds and replace and replace and replace and replace and replace, 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 replace. And then I stop. Right? I don't want to replace the first 11. And this is just a find and replace shortcut, right, to make life a little easier for us. And we'll do the same thing here in a second for third. So let me go and grab all of these ones here, copy and paste. And paste. Oh, our debugger is still running. I forgot. That's fine. And then we'll do a find and replace again. So if you're highlighting a word and you go to find and replace, which is also Control R for replace, it's going to assume you want to replace the word you've highlighted, which is actually really handy too, which is nice. And we want to replace it with third. And I don't want to replace the first set of instances, right? I want to leave these first ones alone here, but I want to go to the second set and start replacing these ones. Okay, so now we've added them all together here. So then we can tell them, you are, oh my goodness, friends, don't let me do bad English. That was awful. My wife would be really embarrassed. She is more of an English type than I am. So the total grade point, right? And then we can do grade point average should be grade point divided by 3. Or if you wanted a variable, right, we could save it as a variable, grade point average, grade point divided by 3, and then we could print that variable. Either way is okay. I sort of like having variables because then you can see the values in debug mode. If you only ever do calculations inside a print, you'll never see the value when you go and debug it. Let's give it a run. So what grades did we get for our 3 classes? A minus, all right. Okay, class number 2, how did we do? A D or a B? D, all right. Didn't do so hot, but D technically is still passing, even though your GPA needs to be a 2.0 to graduate. A D will get you through a class that's a prereq or a required elective. How about our third class? C+, all right. So total of 7, does that check out? So C+ should be 1.3, right? A D should be 1. No, a C+ should be, goodness. All right, let me go look. I don't even remember now. 2.3, so 2.3 plus 1, so 3.3 plus 3.7. Looks like it totals to 7. Divided by now puts us at 2.33333333. So we found our GPA. That makes sense so far? Now, what if we wanted to take this and turn it back into a letter? Like, here's your average letter. Right? I mean, a lot of times we'll use the number, but if we wanted to turn it back into a letter, could we do that? Sure, we could do that. So these sorts of checks here where we say, hey, if something's true, they don't have to be, is a string value equal to another string value? They can be numeric, right? So we can say, hey, if your grade point average is greater than, or you could do greater than or equal to, right? So really, I guess we want to start with if it's equal to 4, that's an A, right? So we can print your GPA is an A. Sure. If it's not a 4, then else if the grade point average is, how about greater than or equal to 3.3? Is that an A minus? Right? If you got to 3.3, all the way up to, but not 4, that's still an A minus, right? So if your GPA is a 3.9, still doesn't count as an A. Sort of a silly way to compare it here, but then, right, we got an A minus. Now with this here, I essentially have a range that I'm doing. I'm saying, okay, if it's 4, great. And we're not like high school, you can't get extra GPA for taking AP classes. Like you're stuck at 4 at college level. There's nothing higher than 4. But if it's not 4, then if it's greater than or equal to 3, that means it's within a range of slightly less than 4 and up to and including 3.3, right, with this notation. Okay, and then what's the next range? Well, if it's not greater than or equal to 3.3, is it greater than or equal to 3? Right? Because a 3 then puts us at a B plus, right? Am I doing this right? Where's my numbers here? Oh no, A minus is 3.7. Guys, help me out here. So 3.7 then. So between 4 and 3.7 is an A minus. Between 3.3 and 3.7 is a B plus. Right? Between 3.0 and 3.3 then, or really just 3, should be a B. Because this if check will never happen if this one's true. Right? As soon as it finds one that is true, the rest get ignored. So yes, I know a 3.8 is greater than 3, but it's never going to check that because it's checking this one first. Right? It's going in order. So we're essentially building the range here with these numeric checks. Right? So let's do, yeah.
So if you were to swap, say, B plus and A minus, and put, for example, 3.8, would it output B plus?
If we swapped these here, like, oops, bring that one in one. 3.8. Yes, because the first one that matches will run, and then everything else gets ignored. So we'd say it's not 4. Okay, is it greater than 3.3? Yeah. So like my original range, which was bad, it would have happened like that. So yeah, the order here is important. So 3, and then 3.7. Now let's go 2.7. Then puts us at a B minus. Right. Greater than 2.3 puts us at a C plus. Greater than 2 puts us at a C. 1.7 puts us at a C minus. 1.3 puts us at a D. And then, no, D plus. And then between 1 is a D. Bless you. Other than that, really just an else then. Else is an F. Right? If you don't have at least a 1.0 or higher GPA, you've failed more classes than you passed. And that's an F. And sort of a weird, you don't usually go back to a letter grade, but we're just having a little fun with it here. So let's give it a shot. So our 2.33333 should land us there then at a C plus, right? We're saying that's about a C plus average because we've gotten 2.3 points or above, but not quite enough to get to the B minus average. So we got an A minus, a D, and a C plus. Let's try it again. So an A minus, a D, and a C plus. A minus, a D, and a C plus puts us at a C plus average. That's what we said. So the A minus and the D sort of wash out, put us in C plus range for our GPA. Sorry, I can zoom that one in, but it stays real low down at the bottom there. This makes sense? So we can build these ranges with the if, else if, else if, else if, because it's mutually exclusive. Now with this, you could do it with a bunch of ifs if you wanted to, but it'd be awful. So what we can start doing is sometimes you need to check more than one thing here. Right? So in our case, we don't have more than one thing to check yet, but we'll go add more than one thing in a second. So we can check 2 cases. Okay, so a pretty common example is whether or not the bank wants to loan you money. Right? Banks are very good at putting this sort of stuff into an algorithm and saying yes or no, we want to loan you money based on if a couple things are true or not. And then they like to say, oh no, the system said no, because banks don't actually do any work anymore. They just look at your credit score and they're lazy. No actual underwriting. All right, so there we go. So we could ask them, hey, have you been late on any payments? Because that's generally a big flag. And if you're late on payments, they don't want to loan you money anymore. So we'll ask them. So we'll say, have recent late payments is an input of, do you have any recent late payments? And then hopefully they're going to enter yes or no. So if we didn't tell them what to enter, we don't really know what we're going to get back out. So I could suggest like yes/no here as a helpful hint and say, hey, tell me yes or no, or Y or N, or we could give them some options here. They still might not pick one of those, but we've got a better chance of getting some decent input if we say, hey, please enter this particular value here, right? And then let's ask them, how about for their income? Okay, so then we'll say, how about your annual income? Now that's probably a numeric value, right? So we want that as an integer, an input of enter your annual income, and like no $sign, right? Because that will mess up the conversion to integer here. And then we can do some rules, right? If you're making like boatload of money, we probably don't care too much if you've been late recently. If you're making maybe in the middle of the road, then we'll say, okay, yeah, we care if you've been late or not. And if you don't make very much money at all, then we don't care if you have perfect credit history, like if you've never been late before, we're just not going to loan you money. Right? We're just coming up with the rules here, right? Feel like it probably works like this in real life, but I don't know because I'm not actually a banker. Okay, so then we'll check. We can say, hey, if the annual income is greater than, what do you think, like 250,000? Now, remember, I think we talked about underscores and numbers, right? You can put as many of these as you want for digit separators. Getting no head shake. So yes, one head shake. Okay. So I always like adding them because it just makes it so much easier to see where those digit groupings are. So say, hey, if you're making more than $250,000 a year, we're just going to give you a loan. Say, here's your loan. Here's your loan. Okay. If that's not the case, then, right? Else if your annual income is greater than or equal to, what should we say, like how about 40,000? Right? So if you're making less than this, but then we care whether or not you've had late payments or not. So we're going to say, hey, if your income is greater than or equal to 40 and your have recent late payments is equal to no. And in Python, we can just use the word and. You say this is true and this is true. Now, ands can be a little tricky sometimes, and there's also ors, which can be a little tricky. So you can and something together. You can take this and this and them together. Or you can take this and this and you can or them together. And I always like to tell people my McDonald's story because McDonald's fries are the worst fries in the world. And if I ever go and order a burger there, like the quarter pounder with cheese, which they promise is cooked fresh, made to order, not kept in those warming trays getting gross and nasty. If you work there and you know different, please don't tell me. I want to believe this. Okay. If they say, do you want fries with that? I say, no, that's gross. I don't want a burger and fries. Your fries are awful. Because if you're saying, do you want this and fries? If you don't want either of those things, you say no. Right? Both have to be true for you to say yes to an and. Do you want burger and fries? Well, you have to want the burger and you have to want the fries. Right? Either side of an and will make the whole thing false. You say no. If they say, do you want a burger or fries? I'll say yes. And then they look at me funny. They're like expecting me to say burger or fries and like answer the question. But as a programmer, if you say, do you want this or this? The answer is yes or no. Right? Do you want a burger or fries? Yes. Well, which one do you want? Do you want the burger? Do you want the fries? Well, ask me that question then. right? Don't ask me if you want this or this. People don't like me at drive-throughs. No, I'm usually not weird like that. Only if I'm in a mood. So we're going to and these together then. So if you make a decent amount of money here and you haven't been late, then we'll give you a loan. Print, here's your loan. Otherwise, else, print, no loan for you. Right? It doesn't matter. Right? So if you've had late payments and you don't make more than $250,000 a year, you're not getting a loan according to the Bank of Eric rules. Right? Sure. So just a little note here, right, for these ands here. So with an and, I'll just say and, I guess. You say true and true is equal to true. True and false is equal to false. False and true is equal to false. And false is false. So the only time you get a true with an and is if they are both true. You have to want the burger and you have to want the fries. Okay. Now, Dr. Ball disagrees with me. Okay, he slightly agrees that their fries aren't great, but his theory is that they're just ketchup vehicle systems. And it doesn't matter how good they are because all you're using them to do is get the ketchup in your mouth. So he doesn't really care if they're gross. So he'll eat their fries. I refuse to eat McDonald's fries. It's not worth it. Like, you only get so many calories in a day. It's not worth wasting them on subpar fries. Okay, so that's ands. And you also have ors. So if you look at this is true or this is true. Okay, so if we want to look at some ors here, we could say, let's do, what do I want to do for an or that's fun? All right, so we'll ask the user if they're bored here. So we'll say, are you bored? Is an input of, are you bored? And again, we'll suggest yes or no here. And then we'll ask if they have homework to do, right? Do you have homework? Is an input of, do you have homework? Yes or no? Here. And now what I'm going to say is, if do you have homework is equal to yes. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. I can get it all out in one breath. I've had a lot of practice. Thank you so much, my friend. I actually just got notified we hit another $100 mark, which is awesome because Twitch won't send a check if it's less than $100, even though it's not a real check. It's like a deposit. So we've pumped $450 into the Student Scholarship Fund now, just because I like Twitch, and Zoom is, I don't know. I have not enjoyed Zoom University. I don't know about you folks. I had one class that I ended up having to drop that we did over Zoom, and it was awful. Probably partly because the prof's internet connection was terrible, and he had a terrible doc cam that he wanted to draw all of his notes on, and like it would go in and out of focus half the time. It's like, oh, it was okay. That's what it is. So if you have homework or are you bored is yes. So if you're bored or you have homework, I'll print go practice Python. Right? If you don't have anything to do, go write some more Python. If you have homework, go write some Python. Okay? Otherwise, well, if you don't have homework, it doesn't matter if you're bored or not, right? So it's only if you're not bored, right? I don't know. We'll just carry on. Because if you're not bored, you're probably doing something. Right? We'll just say carry on. Okay, so this is the or case. So if either one of them is true, the whole thing is true. So with an or, we say true or true is true. We say true or false is true. You say false or true is true. Or you say the only time it's false is if they're both false. So if both things are false, you say no. So if you don't like the fries and you're a vegetarian, you don't want that McDonald's quarter pounder with cheeseburger because you're vegetarian and their fries are gross. So you went up there probably asking for an ice cream, hoping the machine's not broken. Is that a question? Yeah.
Can you run that?
Yeah. All right. So letter grades. So we'll just give them some letters. A. Should get a 4.0. GPA is an A. All right. Payments. Are we late? Yes or no? What do you think? Where do you want to try and land here? Do we have any recent late payments? Yes? Okay. What's our annual income? 249,000. All right, so it is not less than or not greater than 250. It is greater than 40, but recent late payments is not equal to no, so we should be getting a no loan for you response, right? We get no loan for you. All right, are we bored? It's okay to say yes. It's not going to hurt my feelings. No, okay. And do we have homework? Yes. Go practice your Python, right? Because one of those was true, right? Is that what you wanted to see? Okay. Now, yeah.
Correct me if I'm wrong, it's 2 to the n on variable, right? We have 2 variables, A and B.
For like how many possibilities, how many ways you can combine them. If you're ORing together, it's not going to matter as much. So if you're ANDing, then there's only, they all have to be true. So like the half chance, like if you flip a coin 10 times, it's, heads and heads and heads and heads and heads and heads, it'd be 2 to the 10th is your chance for that. Maybe the 9th. I'm bad at math. It's been a while. It's 50, yeah. We could calculate it, I'm sure. But yeah, so that'll go in powers of 2 with because you get 2 choices, yes or no, every time. Now, Python's really cool, and actually most languages will do this. They are smart enough, and actually the people who write the Python interpreter were smart enough to know if you're going to AND something together, and the first thing is false, it doesn't matter what the second thing is. Right? There's no chance the AND will be true if the first thing is false. So what it actually does behind the scenes is known as short circuiting. So the first time it sees a false, it just stops. So if we were to print, or let's say, hey, if false and, capital F false, and 10 equals 10, print 10 equals 10, this will never run. Print 10 does not equal 10, right? Because if you're ANDing things together, if it sees something that's false, it's just going to stop.
I mean, if you put in a variable S instead of 10, that would put an error.
So it doesn't know what it is here. So we could name it something we've used inside of a block that might never have been assigned. So the interpreter is still smart enough to know I've never used apples before, but I could say like if 9 equals 10, apples equals apples, and now I can use the word apples here and it won't crash. Because it sees, oh, you've called something apples before. Sure, you probably know what you're doing here. Go for it. I'll let you shoot yourself in the foot. Because I mean, you're the human. This is just a tool here. It's not perfect. So this will never run because this first part is false. So it saves a little bit of time here with this short circuiting. So this is short circuiting. Circuit evaluation. Excuse me.
You wouldn't have a compiling error because apples is not a boolean.
So Python is really fun. It is truthy. Every variable is true or false. So you're welcome to just say if apples anytime you want, or any variable name that you want. So numeric values, if it's 0 are false. For everything else, if it's not set to none or null, it's true. Just a little awkward here because again, you can do weird things and get yourself in trouble. So I could say like if grade point average, print yes GPA, and like because as long as it's not 0, it'll run. If it happened to be 0, then this part won't run here because 0 is false. So for numeric variables, anything not 0 is true. Else print. That's probably that's worth a sad face at that point if you have a 0 GPA. That's a big sad. You spend a lot of money to get a 0. That's rough. Oh, stop and rerun. Okay, so we'll give it some letters. A. Say no. bunch of money, we're bored, yes, we'll say yes and yes. We have to do Python. Say 10 doesn't equal 10, right? Because okay, we lost the 10 equals 10 here, but it doesn't crash on apples. What is apples? Maybe that might be better here. Yes, apples. Right.
And wouldn't it fail? Just looking at that, wouldn't it always fail?
This one is always false because we're anding together a false with something.
So it would always go to the else.
So it's always going to be the else. Yep. And then this one never evaluates, so we never notice that it will crash. Right? If we change this to true and try to run it, then we say, oh, does apples have a value? Right? It's no good. A, yes. Big number, no, no. And now we get apples is not defined. Right? Because this line never ran. This could never happen. Okay. Just for fun, I saw this. I don't know if I shared in the meme channel or not. There's a thing about programmers. We say x equals x plus 1, and that's a smile face. For math majors, x equals x plus 1. That's a big sad face. Right? If you tell a math major x equals x plus 1, they're like, oh, sad. But you tell a programmer x equals x plus 1, you're like, yeah, add 1 to x. Right? Okay. I thought that was funny. Somebody made it a meme or something. We should set x equal to something. There we go. I'm sorry?
No, I was just saying if you're doing math.
Yeah. And plug x in. Left and right don't equal. Yeah. Math majors get real sad. That's okay. And I think we do have someone who is a math major, so I'm not picking on you. I apologize. It was just supposed to be funny. And now I'm feeling bad. I love math majors. Math is super fun. Next, we looked at anding, we looked at oring. So now we can also, if we wanted to, go even further down the rabbit hole, and you can put if or else blocks inside of other if or else blocks. We can combine them, right? So let's figure out how we do our driver's license, or our driver's insurance, car insurance. My goodness. It's after 7. Should we take a break first, or you want to keep going? Literally the first person to say something.
Sure.
Okay, break. All right, we'll take 10. We'll come back, and then we'll pick it up with if-else inside of other if-else blocks. All right, we'll put some music back on. Hopefully that'll work. Oh, sorry, I was missing some of the chat here, but you're talking about your other school system, so we can talk about that another time. We'll focus on work stuff. So let's put this at 7:13, just like last week. That was amazing. All right, folks. Hey, folks. Sorry, running just a minute behind. It's really nice outside, not so nice in the room. It's a little warm. Oh, I missed your message. You're pushing the code. I'll push that out here now. So here was examples. Excuse me. All right. So a couple other fun things we can do, right? Putting these blocks inside of other blocks then, right? So we'll let's 3x plus 1, is that what it is? Yeah, this Collat's conjecture is really funny. There's a whole interesting video. If you like watching math videos, Numberphile has a good video. I think the guy, what is his name? Veritasium, I think, does one too. He has a really good video on it. Where's just like, this is the Wikipedia page. Here we go. So it says if you take any number and multiply by 3 and add 1, eventually, if we follow this set of rules, we'll get back down to 1. And the set of rules we follow is if it is even, divided by 2. And then repeat the process. If the number is odd, then you take 3 times the number, add 1 to it, and then see what happens. The conjecture is it will always, always, always get down to 1, but it's not been proven mathematically yet. They've done ridiculous amounts of simulations getting this down to 1, and it's really fun here how that would all work. But we could check that. So we could write our own and do this a couple steps here. So we'll ask for them to enter a number. So we'll have our starting number is going to be an int of an input, enter an integer. And it can be any integer we want. Now, we haven't gotten to the point where I don't have to copy paste a bunch of things, so we won't do this like infinitely here, but we'll run it several steps. So the rule was then, if it's even, divided by 2. If it's odd, multiply by 3 and add 1. Right? So let's see what happens. So we can see if a number is even, right? You can say, hey, if the starting number, and I guess really starting number is probably not even good. Let's just do number here. We'll say number modulus 2 equals 0. Right? If you divide out all the 2's and there's no remainder, you're an even number. Right? So if you're even, then we're going to take number and we're going to divide it by 2. So divide equals by 2. If you're not even, you must be odd. So here's our else case. And now the lazy programmer in me wants to flip this here because remember we said Python is truthy? Anything not 0 is true and anything 0 is false. So we could just say, hey, if number mod 2 here, and what this means is not 0. And we know it's either 0 or 1 because when you divide out all the 2's, the remainder is either 0 or the remainder is either 1. So if number mod 2, well, it's not 0, then we'll take number and we'll say times equals 3, right? Times equals 3, and then number plus equals 1. All right, now we have 2 lines, and I feel a little bad about it. So we can change that. We could do it that way, or we could just say number equals number times 3 plus 1. Right? I kind of like this one better. Either way is fine. Right? And then we're going to print the number. Right? We're just going to keep on going, keep on going, keep on going, keep on going forever. Well, so we'll have to copy paste this to do a bunch of things. So maybe we can even check, hey, if number's 1, print we're done. Right? We could do that too. So we could say, maybe we start this with then, if number is equal to 1, print, I don't even remember how to spell this here. Well, that's conjecture. What's conjecture? Sure, I don't know. And then else if, or elif here, if it's mod 2 is true, meaning it's a 1, it's not 0, then we'll multiply by 3, add 1, otherwise we'll divide by 2. And we can just keep on going here, and let's just do it a bunch of times. And again, anytime you've got the same code twice, you should feel bad about yourself. Oh, I missed the print. I wanted to print the number every time. Shoot. This is why I feel bad now. Because now you have to go fix it all these many times. Next week, we'll learn how to do this better and not have to copy paste our code as many times. or not even next week because we're off for Memorial Day. So the week after that, in 2 weeks then. So eventually we'll hit, right, there we go. Print the number, print the number, print the number. I'm going to take out some spaces here. Just makes me a little happier to not have those spaces. And we'll do a couple more here. I don't know how many we need, so we'll just do a bunch. All right, should we try it? So all the other stuff is going to run too. That's kind of a bummer. Let me go. I don't want to comment at all. Okay, we'll just let it run. I'm sorry. I should do my examples at the top, but then you have to read it backwards if you ever want to go look at it again. I don't know. A, yes, and a number, and no. Oh, shoot. We forgot to fix our apples thing here. This had to be false. There we go. Sorry about that. Try that again. And A, yes, number, no. All right, what integer should we try? What should we start with? 7. Okay, we didn't get there yet. We will eventually though. So you get 22, so multiply by 3, add 1. 22, that's even, so divide by 2, we get to 11. Multiply by 3 and add 1, that's even, divide by 2. Multiply by 3 and add 1, because it's odd, it's even, divided by 2. It's even, divided by 2. It's odd, multiply by 3 and add 1. It's even, it's odd, multiply by 3 and add 1. It's even, divided by 2. Oh, 2 more steps, we would have gotten there. So we're so close there, because as soon as you get to a power of 2, you're going to hit 1. So 2, 4, 8, 16, 32, 64, 128, 256, right? Any power of 2 will divide by 2 until you get down to 1. So that's the theory, is that eventually you'll hit a power of 2 in here. Somehow they've not proven it mathematically, and they've got like lots of really smart math people who've looked at this. All right, run it one more time. We'll try 7, and we'll see that it actually is successful. A, yes, a bunch of money, no, and no. All right, integer, 7. I didn't do enough. We got to 2. We need 1 more to get to 1. Try that again. We're so close. It's worth it. I promise. Yes. No. All right, integer 7. We got to 1. Why didn't it print? Did it not? We got to 1. It printed. Oh, we did the last divided by 2. I needed 1 more copy here. So we're even. We divided by 2, and then we printed the number. We printed out the 1. We didn't get to the. All right, let's run it one more time. A, yes, number, no. 7. Collapse conjecture. Hooray. We got there. And you can try with any other number. You want to try a different number? You're still excited, right? 13. All right, let's try with 13. 13. Ooh, 13 hit fast. Right? Again, this is a little ugly here. We're doing it every time. Like, okay, we'll figure out how to clean this up later in the next couple weeks. Well, I mean, like where we hit collapse conjecture over and over and over because we stayed at 1. Like 3, or I'm sorry, if you did this operation to 1, you'd hit 1 would be multiplied by 3, would turn into 3. 3 plus 1 is 1. We give you 4. 4 is even, divided by 2 is 2. 2 is even, divided by 2 is 1. Right? You get a loop essentially, but eventually it will like drill down to 1 if you stop at 1. Otherwise, you have an infinite loop. Yeah, I think Lord Taylor, I just didn't have enough copies here. So there apparently was a guy who did this for ridiculous amounts of numbers out in England. I don't know why. He was a mathematician hobbyist or something like that. And he had a book out in their archives, which is really cool, like all the things. And he was looking for the number of digits in the answer or something like that. If there's some kind of relationship, I forget what it was. The video was really cool. But if you go look this up, there's a fun video about it somewhere that is totally not related to any of this, but it's fun. Then the numbers are larger than Python can handle, right? Like if we wanted to actually like try and, you can't prove it mathematically by making Python do it a bunch. Because mathematicians will say, well, just because it's true for the first 10 gazillion numbers doesn't mean it's true forever, which is fair. Right? That's not actually a proof just because every time we've seen it is true. Right? That's not a mathematical proof. So they haven't yet. Doesn't mean it can't be done. I don't know enough about math to know whether or not. So, I mean, to disprove it, all you have to do is find one example that doesn't go down to 1. But to prove it, you need to show somehow that it is always true. Like you will always hit a power of 2 with this 3n plus 1. And apparently you can't do that, or they haven't figured out how to do that yet. I don't know. I don't know enough math. That's at some point, if I ever had more free time, I'd like to go take more math classes because it's entertaining. Yeah. So, right, if else if we haven't embedded anything yet. Sorry. If we wanted to clean this up here, I don't recommend this because this was probably a bad example for that. We could put all of this inside of one of these if else if blocks and nest it there so that if it's the number 1, it won't keep running forever. I don't recommend that. That's going to be ugly here. Because no, we'll do something a little easier that's embedded here. So we'll do that. We're going to look at insurance rates, right? So to determine insurance rates, the first thing they're going to figure out is whether or not you're male or female, because teenage men, or even in your 20s, are statistically the highest risk drivers. So they're going to charge us more, right? So they need to figure out for male or female. So we'll ask them here. So we'll say your gender is an input of enter your gender, and then age. We'll say that's probably an integer. Most people don't say like 23 and a half, right? So it's probably fine as an integer. Say enter your age. Okay, with those 2 pieces of information, we can figure out how much we need to pay up the nose for our car insurance, being one of the highest insurance rates in the country here in Michigan. So we can say, okay, if gender is equal to male, and then inside of this block, then we'll say, okay, if age is less than, I think it's 25, we'll say your rate is probably like $250 a month, right? If your age is not less than 25, then you get a slight discount, right? We'll say you only have to pay $150 a month. Right? I'm making up numbers here. I have no idea. I'm sorry? Age? Yeah, it's an integer. So we can say is an integer less than. Oh, yes, thank you. Yeah, int of an input. Thank you. You get some bonus points here. Actually, my my bot here is really good at bonus points. You can say bonus points for at oh goodness. I'm bad. I'm terrible with names. So say guy in front. And guy in front gets bonus points. 8 bonus points have been given. Okay. It's like, whose line is it anyway, though? They're not actually worth anything. They're just for fun. Yes, thank you. Input. Yeah, so we can convert here. So if it's not male, then if the gender is not male, then we have an else here, and then we can. So younger females still are charged a little bit more, but not quite as much. So we can say, hey, if age is less than 25, then our rate will be, we'll just say $200 a month. And otherwise, then our rate is equal to, we'll just say $150 a month. I think they start charging everyone over 25 the same rate. I feel like. I don't actually know that for sure, but I know young males get charged the most. Now, this is an if inside of an if, right? So we're saying if this is true and this is true, we could technically write this then with some ands and ors logic if we wanted to. So it's all about what's going to be a little easier for us to follow here and what's going to be kind of cleaner to read. So we can get the same result if we wanted to, right? Writing in the other direction. So we could say, hey, if gender is male and age is less than 25, then our rate is going to equal $250 a month. If gender is female and age is less than 25, then the rate would be, we said, $200 a month. And then else, right? Because right? That's just the other case here, and our rate will be 150. So either of these will get the same job done here, right? Now, if you have more than like 2 or 3 things, though, you're probably better off nesting them together rather than trying to have a bunch of if else, if else, if else, if else's. It's up to you. Whatever is going to make the most sense to you is if you start having more conditions to check in here, right? We could also add in like and previous crash, right, equals yes, right? You're going to have one rate, otherwise in previous crash is no, or it gets a little bit crazier here. You can do all those sorts of things though. Should we try and add those in? We'll charge you more money if you've had a previous crash. Previous crash equals an input that have you had a previous accident? And again, like yes or no here. So, well, what are we going to do? So in that case, then, right, what do we have to say? So if you've been in a previous accident, we discharge another $50 a month, right? We could do something like that. So we could put that in here if we wanted to. So our rate, maybe we should just do this as integers here, because then we can do easier arithmetic. We'll do 200, 150, 150. We'll put these back to the numbers here. Yeah, so that would just add to it. Then we don't necessarily need to go and change every single place. We could just, at the end of that, then say if previous crash is equal to yes, then we'll take our rate plus equal 50, right? We'll just charge you more money, right? And that could be the same in either case. If you wanted to do it all in one line, you could, right? You could add in a bunch of other cases, but it probably is uglier. So a lot of that is just looking at the logic, right? If this is independent of the other things, I can do it after. If it depends on the previous things, maybe if you're male and you had a previous crash, we'll charge you 75. If you're female and have a previous crash, we'll charge you 50. We'd have to do it separately or have its own set of logic here. Yeah. So it's the same thing as saying rate equals rate plus 50. So it's the shortcut because us programmers are lazy, saying I don't want to have to type rate twice if all I'm doing is adding something to it. So it's a combined assignment operator. Yep. Yeah, any operator you can do a combined assignment operator with. Yep. Yeah, we did the divided equals up here. We can do the times equals, right? Yep. Yeah, it's just a shortcut. And that was pretty common. Right? Generally, like after you've seen it a couple times, it makes a lot of sense. So I don't feel bad using it as a shortcut. Okay, so we can put ifs inside of other ifs if we wanted here. Again, just depends, right? If you prefer this, great. If you prefer this, great. They both will do the exact same thing here. That's where it's really an art. Right? It's which one do you like, this way or that way? And then this one you could even write backwards if you wanted. You could do the age first if you cared, right? You could check, hey, if the age is less than 25 first, and then check for gender. Lots of different ways to write these. Not too big of a deal here. Let's take a quick look. So I think we got a lot of these things here. Our logical operators. Oh, the is a really good one here. So the is operator is going to check if they are identical or if they're the same thing, which is a little weird. So if I say, let's go back. I'll just do it down here, I guess. So we'll print first class letter grade is the second class letter grade. So this should either be a true or false, right? So is going to check for identical. And identical is not the same as having the same value, right? So eventually when we run this here, we do A and A and A, and yes, numbers, and yes, and 13, I think. Male, 5, previous accident, yes, sure. We got true. We should not have. This one gets weird. Should. Operator. Come on. Let's let Python figure it out here. Here's our Stack Overflow. Is usually pretty good here. yeah, so is actually checking the IDs of things, which weirdly, those got the same ID. So I think it's doing behind the scenes, just saving some time here. Let's check if it's, I think it's A. I think ought to fail it here. Yeah, is with a literal. So this won't even let us like figure that out. It's going to fail here. So usually made for comparing variables. I don't know why it's complaining here. Say equals A. Wonder if we can compare this test. We'll try that. A, and A. Yes. Numbers. No. 7. Fail. 5. No. Okay. It's shortcutting something here. Those should not. Is being weird. I'm sorry. Yeah, this ID last week, or maybe even the first week, we looked at everything as an ID and a type, and the ID is essentially the internal value where we're storing it. So it'll be clever and say, hey, if you've got two things with the same value, we probably aren't the same ID. I wonder if I can do test equals B. Maybe I can do this. We'll start it at B, make it A. I change it. A. No. 15. 25. No. All right. I'm fighting with it. I'm sorry. Still saying true. So it's a special case checker. Once we get further along and start working with objects, it'll be a lot more important. When we're just dealing with small literal values, numbers and strings, it's not going to be as important. Those later chapters, where did those ones go? Once we start list, dictionaries, tuples, objects, it'll behave a little different here. Generally, we don't use is or is not for basic arithmetic operators or comparisons. It's more of a special case. We'll get to those ones later. And then your equals greater than equals less than are backwards. So you got to be careful. The order does matter here. So it's less than or equal to or greater than or equal to specifically with those. We did ands, ors. There's also a not operator. So not is the opposite. Right? So not true is false and not false is true. Sometimes you want to use it. Other times you just are going to change your case. So it doesn't matter quite as much. Conditionals, we did those. We did else's, we did chains, we did nested. Aha, exceptions, here we go. So if we were to give some bad inputs here, where were we doing some numeric value? So if I ask for a numeric value and I don't give you a numeric value, it's going to crash hard. Let's see, we did it here for the income. Right, so if we give you an income value that's not numeric, AAA, no payments, so numeric value for income here, if I give it like 10, it crashes and I get this error. I think we looked at these last time. Value error, invalid literal for int with base 10. I give it 10 as a string here. It couldn't convert. I can bring that up a little. No, that's about as high as it goes. So the way to not crash here is to do this, which is a try and except. So we're going to use a new block here. We're going to put it inside of a try. So you put try and you do something. And then if that exception happens, what do we want to have happen instead? So we can put in here, then, we're going to say try and do this thing. So you start a try block, where you want to not crash if a bad thing happens. Right? And then if the bad thing happens, we do an except. We say except. Expect? No, except. There we go. So if the bad thing happens, here, run this. And we'll print, or we'll just say annual income maybe is 0. So if I couldn't figure it out, I'll just assign it to 0 so the rest of my program can keep on running. right, with some kind of default value. You've got lots of choices here. We can even print a message, print invalid entry, run again, invalid. But we could continue on if we wanted to. So we can give them some sort of default value if we couldn't figure out what it was. And now it won't crash if I enter 10. A and A, no 10 here, and it just keeps on going, right? We get no loan because we had no income. So these are really handy anytime we're dealing with inputs to see if they're good or bad, right? And then, so we were looking at for the project, right, to figure out whether or not something was going to be evenly divisible, right, by our post distance. So for this then, right, we can print out a message saying, nope, you picked wrong distances, you dummy, that's not going to work, and just bail, right? Or we could assume you just want the post distance to be the width or something. Again, that might not even work if their lengths and widths don't work very well, right? If you have like a length of 10 and a width of 12, you're probably going with a post distance of 2, right? Because you can't be a distance of 10, right, if you have a length of 12 on this side. So it's probably easiest to just bail on it and say, hey, this was no good. So you don't even need to try except here. This is just an if check. And say, hey, if the value is bad, we'll print out an error message. We're done. Else, let's just keep on going. If you want to not have to have everything indented, though, you can exit. So that's like a hard stop here. Where do we do our try except? And then, so instead of even setting it here, we can just call exit. So that will just end the program here if we call exit. So A, and A, say yes, and we'll say 10. Invalid entry, please run again. Program exited. So exit here will just hard stop. And then this, otherwise you'd have to have like inside of the if block error and then else. All of the code would have to be tabbed in inside the else, which is really ugly.
Can you do a go-to statement?
No. No go-tos. Yeah.
Can you do something that, like, I'm thinking about a project, like, they enter a value, like, in the middle of the program, they send you that, and then you just messed up.
We're gonna do that in chapter 5. Sorry, we're not there yet. Yeah. You can make something repeat once we get to chapter 5.
Oh, okay.
Yep. So we'll get there, but for now, just bail on them and say game over. But like iterating is like this while statement is what you do essentially. But it's okay. We're only in week 3, so not too bad here. We'll just end and say you gave me bad value. No offense. Like try again, and that's okay. Right? Not too concerned there. So that'll hard stop. All right, let me add this here. So here's more examples. Those are not the best commit messages. I'm sorry. It could be more specific, but all right. So we got those. All right. So we need to work on our lab exercise, and then we'll have the rest of the time to get moving on that project. Again, due next week. So let me come back to class here.
Quick question about
Yeah.
the project. Since we don't have class, we just publish it Sunday night.
Or anytime Monday, like anytime you want, you can commit it and push it. Yep. Yeah, a couple of people turned it in already because they're overachievers, and that's okay. No big deal. Yeah, so because you're using the private repository, no one else will be able to see it, just me and you. Yep. We do a new lab. So this is lab 2. To conditionals. There we go. So this one, again, we're going to pretend next week doesn't happen. So by June 6th, 6 p.m., do 10 points for the lab. And points only matter within the labs category. And your lowest lab is going to get dropped as well. So everyone gets a freebie there. Classroom.com. Get your link here real quick. 2131. 31 summer. This is lab 3, right? If I can count right. Oh, lab 2. That's where we started with 0, right? Okay. Apparently I can't count right. use our Python template. All right. Submit the URL to your main.py file. Put this one in labs. All right, so we are, we're going to write a rock, paper, scissors, lizard, Spock game. Ask the user to choose a item to throw. And we're going to randomly generate a throw for the computer. Display win, lose, or draw. Okay, so rock, paper, scissors, lizard, Spock, I think was Sam Cass, I want to say, added in 2 more options here to the traditional rock, paper, scissors game. So we Google this one real quick. Scissors decapitates lizard. Scissors cuts paper. So everything will beat 2 and lose to 2 now. Lizard poisons Spock, and lizard eats paper for its win. Paper crushes lizard, and paper crushes scissors. Okay. Spock smashes scissors, and Spock vaporizes rock. Sure. The paper covers rock, and paper disproves Spock. I don't know. That means they wins somehow. So all of them have 2 things they'll win against, 2 things they'll lose against, and they'll tie if they play against themselves. Okay. So just do a quick Google. It'll come up with which one is which. Oh yeah, here's the hand motions too. You can do Spock, lizard, right, for yours. I'm sure this won't cause any fighting when I tell my kids how to play this game. Because they're like, no, you had a different hand up. Sure. All right. So to make the computer pick one randomly, did we do random last week? I think we did, right? No? Okay. So that's all right. So to pick a random number, then let's add that one in here real quick. Didn't we look at the random file? We opened it up. We didn't actually use it though, right?
We tried to find the random file.
That's right. We didn't find the file. I thought we found something. We didn't find math. We found random.
Oh,
right? I think that's what it was. So to use random, we'd say random dot. I think it's just next int. Now you give it a range here of like 1 to 5. So we'd have to say random value is random next int 1 to 5 will give me numbers 1 through 5, including 5, which is weird because most languages don't give you this inclusive. Random value 1 to 5 inclusive of both ends. I think that's what it was here. We can print value. Should do it here. Let's try it. A, yes, number, no, yes, 7, male, 25, no. Oh, didn't like it. I didn't import random. So sorry, at the top of your code, you're supposed to say import random. There we go. So we're telling Python, hey, please give me the random library that you know about at the top. I thought PyCharm would do that for me. It was weird it didn't. So you start at the top with import random. You can technically put these anywhere, but it's bad form. You want all your imports at the top of your file. That's considered best practice. Then we can use random. I think it should be next. Random. Randint. Here we go. Random.randint 1 to 5. Not next int. Sorry. Will give us a random value, and then we can print out that value. I should have put it at the top. Here, just stop. We'll put that at the top. We don't have to run everything. So every time I run it, I should get a different value. So that was a 4. We run it again, stop and run. I get a 3. Run it again, I get a 3, a 2, a 2, a 1, a 3, a 4, 4, 2, 5, 5. Right, pick a random number. So you can use that random value then to represent one of the 5 choices: rock, paper, scissors, lizard, or Spock, if you wanted. So the other thing we didn't do yet is casing for words. Here we go. So if I enter a lowercase a, is it going to equal a capital A? No, Python is case sensitive. So what happens behind the scenes, each letter is actually technically stored as its Unicode value. So Unicode is a way of storing values as numbers here. So long time ago, we've been doing it forever now. 41 is an A. It's the Unicode value 41. So the numeric value, so when the computer stores a letter, it stores it as a number, and then it just converts it for you. A lot of everything eventually gets stored down in bits. And I think we kind of skipped over that. I said read chapter 1 because it's interesting. If you actually read chapter 1, right, he had some of that in there, right? So the only thing our computer can actually do is store yes or no, a bit on or off, and we store groups of them. 8 of bits make a byte. We store a bunch of bytes together to make things. So you can store a numeric value for a letter, and you store a bunch of numeric values, and you get a word out. So capital A is 41, lowercase a is 61. No, this isn't hex. I'm sorry. Ugh, gross. Hexadecimal notation. Thought that was wrong. Where you are base 16. This has reasons too. You can learn about it in other classes. It's not all that important, but it's a numeric value that you eventually get. So a single letter here. So if I were to do, let's say 65 to, what's 26 plus 65? 80, 94, I want to say, is a random number, and then I can print the character representation of that number. So char here, or chr, is a single character. So I can turn a numeric value back into a character if I wanted here. So let's run. And now 87 is the capital W. Sure. Let me find one that's not in hex here, because that'll make a little more sense. Here we go. So this is the decimal version of here. So starting at, where'd it go? They jumped. Why did they do that? Here's my letters. Okay. So starting at 65 is a capital A. So capital W here is an 87. So 65 to 90. Do I not know how to add things? 65 to 90? I don't know how to add. Yeah. 26 plus 65. But 65 is the first one. So like really we're adding 25 to it. Right? Because this one is the last. So there's 26 different values between 65 and 90 because math. So we can get random values here. So you can convert them back if you want. And each time you'll get a different letter, which is fun. Right? And I can see the values turn into letters. Or if you wanted, you could take letters and turn them into numbers. So I could print, to turn a letter into a number, it's ord here for the ordinal value, which doesn't mean Unicode or ASCII. I don't know why. I didn't make Python. So I could say ordinal of E here, and comma, the ordinal of R, and the ordinal of I, and the ordinal of C. So if I wanted to print my name out in the ASCII values or Unicode values, it's 69, 82, 73, 67. ERIC. So if you were to store the value of Eric in memory and make a variable for name and store Eric, you would actually store these values in memory. How do we even get here? I'm sorry. Oh, uppercase and lowercase. There we go. So an uppercase value is not the same as a lowercase value, right? The lowercase e is a 101, and for some reason they put these in between them. Again, I don't know why, but there's funny characters in between before you get back to the lowercase letters, right? And then you have the set of lowercase letters. So when they compare values, right, uppercase A is less than uppercase B because it compares the numeric values. So you can do these relational operators with letters because it just turns them back into numbers, weirdly. But for case values then, if we don't want to have to say, okay, is it equal to A, or is first class letter grade equal to lowercase a, you could do this, but it's a lot of typing, right? That's not ideal. So what you could do instead then, you could say, hey, first class letter grade, if you put a dot here, you have is it upper? Yeah, dot upper will take whatever text is in here and will make it all uppercase. Now there is no uppercase minus sign, so this should work out okay, right? But if I take your input and I make it uppercase, then I can compare it to an uppercase A every time. Now this is still obnoxious because I have to change it every single time up here, right? That's no fun either. So what's probably better is I could say, hey, I want your input dot upper, right? Whatever you enter here, then uppercase it and save it. Or you could do it in two different lines if you wanted. Right? You could say third class letter grade equals third class letter grade dot upper. Right? Either of these would work for you, whichever you like. I'm fond of the least typing most of the time, as long as it's still readable. So I think if you see this, you'd say, oh, okay, you're going to take the uppercase version of whatever they typed in here. Yeah. So right here, we'll learn that next week. They are upper is a function, and functions need parentheses. Like input needs parentheses because it's a function. We'll talk more about it or in 2 weeks. So some things you can put something inside, like input, you can put something inside of it. Some things you don't have to put anything inside of it. And I think this ought to work for us then. Upper. Let me just double check. Python upper.
Can you take a random between defined letters?
But you'd have
that
to.
Would be make it easier for our lab, right? RSPLS, and have it choose between random.
It has to be ranges. So you're better off like doing random 1 to 5, and then if it's a 1, do something. If it's a 2, do something. If it's a 3, do something. If it's a 4, do something. If it's a 5, do something. Yep. Oh, I never saved this. I'm sorry. Let me save this here. Okay. So that's our conditionals lab we're going to work on. So yeah, so comparing here then, you got to be careful. If you're only looking for uppercase and they enter a lowercase value, it's not going to work very well. So generally, either changing their input or changing it when you compare. Now, if you're only comparing it once, go for it. Change it when you compare. If you're going to compare it more than one time, you're probably better off changing their input, right? You want to do the least amount of work. You want to be lazy, right? Save yourself some time here. Okay. So let me double check if that all works here. So let me do all lowercase a's here, A, and we get 4.0. So doing all lowercase with 3 different methods, right? Whether or not we're checking upper or lower, checking, as we're doing it here is fine. Using upper on the input or in 2 steps, getting their input and then changing it to uppercase. They all work here. So it seems like it worked out okay for us. Okay. All right, so I got 8 o'clock. Not too bad. We spent about half the time getting bored listening to me. We'll have some time to work on the lab. We can work on the project. And I did, hopefully you saw posted here, my office hours. I saw so I have 5 classes. So we went out to a bunch of people, about 130 or so, I think, across all the classes. So of the like 40 people who answered me, I picked the best hours. So Monday and Tuesday afternoon catches a big group of people, and then Wednesday and Thursday night caught another big group of people. Weirdly, most of them said Monday night was the best. I'm assuming was the other classes who thought Monday evening was the best. And that just, I'm not going to have office hours Monday evening, go figure. But I'll be here on campus generally about 5:30 or so. I didn't even bother putting in here. It made it look not as pretty. Like this, like 2 different groupings of days and times was probably enough. So I'll be here Monday before class, Monday and Tuesday virtually. We can meet over Zoom or Discord. Wednesday or Thursday virtually, we can meet as well. And then technically they don't close the building until 10:30, so we can meet, after class as well if you want, because class goes till 10. We've had public safety chase us out before, and that's fine. Hey, White Paladin, thanks for dropping by. Happy Blur's Day. Yeah, so I think that's what we got. So I'll post the quiz for chapter 3 later tonight. I have to go write it real quick. Trying to make most of that come out of the text, so that you have another incentive to go and read the book. Honestly, that's why there's quizzes, like to get people to read the book. You'll, depending on how you are as a student, maybe you'll get enough out of lectures and you never have to crack the book open. I was like that as a student, but then you'd miss important things in the book occasionally. So we have the quizzes to be your reason to go and open the book and go and do some reading. hopefully it's not all like I'm just going to click Control F search and find on like here's a couple keywords, but at least you're still reading some of it at that point. Like I can't make everyone read, so hopefully those are free points. The labs should be, before you walk out the door, I'll make sure it's done for you. If you want to stay, great. If you're done and fried and want to go home. That's okay. We can work on it later. I'm happy to work on labs with you during my office hours. And if these ones don't meet, I can't make everyone's times. Shoot me a couple times that do work for you, and I'll try and get one of those to work. Generally, dinner times are bad because I'm with the kids. And then weekends, after the kids are in bed, I'm happy to meet with people, most if I'm not going anywhere. So um, frequently meet with people late at night. That seems to work out for a lot of people. 6 a.m. is rough. I don't like mornings. I got into computers to not have to do early mornings. So, right, I think that's all we got today. So we got the lab to work on, and then the project, and then we'll pick up chapter 4 in 2 weeks. All right, cool. We'll end the recording here. So if you folks are remote and want to meet, just shoot me a message or shoot me an email. I'll put you in the queue, and I try and just walk around and help people and go from there. Thanks, everybody.